In this lesson, we are going to learn about X-rays. X-rays are electromagnetic waves having wavelength from 0.1 angstrom. What is 1 angstrom? 10 to the power minus 10 meter to 100 angstroms. X-rays were discovered by accident. A German scientist, Wilhelm Röntgen, was doing experiments on cathode ray tubes. By some chance, some photographic plates were there in his table. Later, when those photographic plates were developed, he found that pictures of the bones of his wife's hand were there in those photographic plates. He was surprised how these have come. Some unknown radiation must be there. Unknown is called X in algebra, and that's why he called them X-rays. So Röntgen found that highly penetrating radiation of unknown nature is produced when fast moving electrons strike a target of high atomic number and high melting point. In this process, kinetic energy of electrons is converted to X-ray photons. The exactly opposite process, where energy of photons is converted to kinetic energy of electrons, is photoelectric effect. So remember, production of X-rays and photoelectric effect are exactly opposite processes. Now X-rays are produced in an X-ray tube, obviously, right? That is called Coolidge Tube. So now we are going to understand Coolidge Tube. Coolidge Tube looks like this. This has got two arms. Here we'll have a cathode. This cathode is connected to a small battery that heats this cathode. Here we have got a target, the anode. This anode is connected to the positive terminal of a big battery that gives the accelerating voltage, and the negative terminal of this battery is connected to the cathode. Now because of this battery, the cathode will get heated up. When you heat this, electrons are liberated from the cathode. That process we call thermionic emission. So because of heat, electrons are liberated from cathode. The electrons move towards the anode, the target. Because this is plus, this is minus, electrons like to move towards the plus side. So electron move towards the target. When the electrons hit the target, they suddenly decelerate. Whenever a charged particle accelerates or decelerates, it emits electromagnetic waves as per Maxwell's electromagnetic theory. So now, from here we get X-rays. And that's how X-rays are produced. The X-rays produced by deceleration of electrons are called continuous X-rays. They have got a German name because Röntgen was a German scientist. These continuous X-rays are called Bremsstrahlung. These continuous X-rays are produced due to deceleration of electrons. Electrons are coming from the cathode, they reach the target, they gain kinetic energy. That kinetic energy is given by charge into potential difference. This potential V is the accelerating voltage provided by this big battery. When this electron hits the target, the entire energy may be converted to an X-ray photon or anything lesser than that. So the maximum kinetic energy that the electron gains is K equal to EV. When this full thing is converted to an X-ray photon, we get the maximum energy X-ray photon, whose energy is given by this formula HF maximum. And this is also equal to Hc by lambda minimum. Therefore, in this process, the minimum wavelength X-ray photon that we get is having a wavelength of Hc by EV. This is the formula for lambda minimum. And this is also equal to lambda minimum is 1242 if you take lambda minimum in nanometer divided by V in volts. So this is the formula for minimum wavelength of an X-ray photon. The continuous X-rays have all range of wavelengths starting from lambda minimum to infinity, and lambda minimum is given by 1242 by V in volts. Okay, this lambda minimum will be nanometer. The actual formula is lambda minimum equal to Hc by EV. Now continuous X-rays, if you want to decrease lambda minimum, then you have to increase V. So as V increases, lambda minimum decreases. So the important thing you need to remember about continuous X-rays is that they depend on the accelerating voltage. As we increase the accelerating voltage, lambda minimum decreases. Continuous X-rays are produced by deceleration of electrons. When the entire energy gained by an electron is converted to X-ray photon, we get lambda minimum X-ray, and that lambda minimum is Hc by EV, and that is equal to 1242 by V in volts. Then you get lambda minimum in nanometer. These are continuous X-rays. They are also known as Bremsstrahlung. Bremsstrahlung is a German word.